composite functions. It's when two, or maybe even more for that matter, functions sort of combine together to create some new function. It's like this. So you start with your domain. In this one I've just got 1, 2, 3, 4, 5. We plug it into this function 2x plus 1, and the 1 becomes 3, the 2 becomes 5, the 3 becomes 7, the 4 becomes 9, the 5 becomes 11. But we don't stop there. We then get those numbers and plug it into another function, let's say 3x squared. So now the 1 essentially has become 27. And the 2 has become 75, the 3 has become 147, the 4 has become 243, and the 5 has become 363. So we've applied two functions to the number. The equivalent composite function could have been achieved by just substituting that x into 12x squared plus 12x plus 3. That would be the composite function. The notation for that then is essentially what we're saying is we're substituting all of function x into g of x. So we write it that way. Well, g and function x is replacing the x. Now, if you did it the other way around, you're not necessarily going to get the same composite function. If I was to do it the other way and substitute g of x into function x, well, let's actually do it. Sub 3x squared, so everywhere I see an x I replace with 3x squared, and I actually end up with 6x squared plus 1. You'd have a different composite function. So the order that you do the composition matters. Well, how do you find the domain and range of these composite functions? For x to be in the domain of the composite function, so the answer, two things. It's got to be in the domain of gx, because if x wasn't in the domain of gx, well then you couldn't have substituted it into f, because you haven't got it there. So that's the first condition. But then the answer that you get when you sub the x in, that's got to be able to be put into the domain of function x. Because again, if it's not, you can't substitute the answer in. So they're basically the two ideas. Now to work out the range, so the value of the answer, when you've done your composite, you've subbed it in twice, it will end up being in the range only if x is in the domain. If you can't substitute that number in, then you can't get the answer. Alright, let's have a look at this example. Let's say function x is 2x on 4 minus x and g of x is 1 on x squared. And there's the question. Find the domain and range of this composite function. Well, the first thing to do is look for the domain and range of each of the individual functions. So 1 on x squared, well, I've got a pronumeral in the bottom of the fraction. We know bottom of the fraction can't equal 0. So for this one, and I'm using our set notation here, x would belong to the real numbers but excluding 0. The range, well, I'm only ever going to get positive numbers there because I've got 1 on x squared. It would be impossible to get a negative answer. So that's gx. Let's have a look at function x. The domain of that one, again, bottom of the fraction can't equal 0. So we get all real numbers, but we can't substitute in the number 4, so excluding 4. Its range turns out to be all real numbers, but you can't get the answer of negative 2 for this one. So let's now try and get the domain and range of this composite function. So we said x, first of all, must be in the domain of gx. So if I have a look at what we wrote for gx, 0 is not in the domain of gx. So I know, right, x can't equal 0 for this composite function. Cannot substitute it in. But then the answer that we get out, and we're only getting answers out that are positive, must be in the domain of function x. Now function x had an exclusion itself in 4. If I'm substituting gx into function x, then I can't substitute the number 4 into it, because we saw that the exclusion in the domain for function x is 4. Therefore, the answer from g of x, it might produce the number 4, but it's no good to me because I won't be able to substitute it into the second function. So that's what I'm saying here. We said that g of x can't equal 4. That's what we're basically saying. Because whilst the answer might give me 4, I can't then go and substitute it into the function. So 1 on x squared can't equal 4. Well, that means plus or minus a half also are excluded from the domain here. So we've actually got 3 numbers that won't work for this composite function. So we'll have all real x except 0 plus or minus a half. So there's our domain. Range. A value of the answer will be in the range only if the x is in the domain of the function. Now what I like to do is work out what the actual composite function is. So let's substitute gx into function x. So 1 on x squared, everywhere I see x, I'm putting that. I end up with 2 on 4x squared minus 1. Now if I had just looked at this and said, hey, what's the range of this function? I would have ended up with that. The range would be less than or equal to -2, but also greater than 0. That's what I would have come up with. Well, that's fine. But remember, that's not what I'm looking at. I'm looking at a composite function, and we have some other things that are happening. I know I can't substitute in 0, and I can't substitute in plus or minus a half. Well, plus or minus half, not an issue, because I couldn't substitute that into this one anyway, because it would have created 0 on the bottom of the fraction. But I could substitute 0 into this one and get an answer. If I substitute 0 into this one, I would have got the answer -2. So what we're saying is, because x is not in the domain of this composite function, I can't get the answer -2. Which means I have to adjust the range of this function, what it normally would be. It's a minor difference, because you'll see that originally it would have been less than or equal to -2, but what we're now saying is, well, actually, we can't get -2. So my adjusted range for the composite function just becomes, well, it would be less than -2, but also we could get numbers that are greater than 0. And so that would be the range of our composite function. Let's do it the other way around. Let's see what happens if we substitute function x into g of x. So remember, x must be in the domain of function x. Well, if we have a look at function x, 4 is excluded. So I know, right, 4 is not going to be in the domain of my composite function. Function x must be in the domain of g of x. All right, well, we said with g of x, we can't substitute in 0, which means the answer to function x can't be 0, because I can't substitute it in. So 2x on 4 minus x can't equal 0. Well, if I was to solve that, that just gives me that x can't equal 0. There's my domain of the composite function. Everything except I won't be able to substitute 0 in, and I won't be able to substitute 4 in. What does that do to my range? Okay. So value of our composite function is in the range only if x is in the domain. So it can only be in the range if I can substitute that number in. Let's work out what the composite function is. 4 minus x squared on 4x squared. So if that was just my function, I would have said, oh, okay, the range, I'm only going to get positive numbers here. Or I could get 0, I suppose, because if the top of the fraction was 0, that would be possible. That's if it was just this function, but it's not just this function. It's a composite function. So we now have to look at what we excluded. Now if I substitute 0 into this one, well, I wouldn't be able to anyway, so that's not an issue. But I could substitute 4 into this one and get an answer. But we've already determined we can't substitute in 4. So x can't equal 4, so I cannot get the answer of 0. So again, it's a minor adjustment, but instead of being greater than or equal to 0, that means my range is just greater than 0. So that's how you investigate your domain and range of your composite functions. Domain, look for the exclusions. Once you've got the exclusions, work out what the composite function actually is and just do a normal, what's the range of this function? And then say, but hang on, I've got these exclusions, so I can't get those answers if I was to substitute in. Let's check and see if I could do that. And then that might create another exclusion from your range. One other thing there's this thing called the empty set. The empty set is the set that contains nothing, you'll recall. Well, if the domain of a function is the empty set, I know it sounds really weird, what numbers can you substitute into this function? Nothing. You can't substitute anything into this function. Well, hang on, what is this function that you can't substitute anything into? We call it the empty function. It's just a bit of terminology. But it's hard to even imagine what an empty function would be. How could you have a function that you can't substitute anything into? But that's what it is. If you ever see that term, that's the empty function. All right, just a couple of, well, hang on, how many we've got? 1, 2, 3, 4, a few questions there to do.